Good morning. My name is Disha and I am a second year student of chemistry honors. Today I am going to read chapter Alcohols, Phenols and Ether of class 12th Organic Chemistry. Alcohols, phenols and ether are the basic compounds for the formation of detergents, antiseptics and fragrances respectively. You have learned that substitution of one or more hydrogen atoms from a hydrocarbon by another atom or group of atoms results in the formation of an entirely new compound having altogether different properties and applications. Alcohols and phenols are formed when an hydrogen atom in a hydrocarbon, aliphatic, and aromatic respectively is replaced by OH group. These classes of compounds find wide application in industry as well as in day-to-day life. For instance, have you ever noticed that ordinary spirit used for polishing wooden furniture is chiefly a compound containing hydroxyl group ethanol? The sugar we eat, the cotton used for fabrics, the paper we use for writing are all made up of compounds containing OH groups. Just think of life without paper, nor notebooks, books, newspapers, currency notes, checks, certificates, etc. The magazines carrying beautiful photographs and interesting stories would disappear from our life. It would have been really a different world. An alcohol contains one or more hydroxyl groups directly attached to carbon atoms of an aliphatic system CH3OH, while phenol contains OH groups directly attached to a carbon atom of an aromatic system C6H5OH. The substitution of a hydrocarbon in a hydrocarbon the substitution of a hydrogen atom in a hydrocarbon by an alkoxy or aryloxy compound yields another class of compounds known as ethers. For example, CH3O CH3 dimethyl ether. You may also visualize ethers as compounds formed by substituting the hydrogen atom of hydroxyl group of an alcohol or phenol by an alkyl or aryl group. In this unit, we shall discuss the chemistry of three classes of compounds, namely alcohols, phenols, and ethers. The classification of compounds make this study systematic and hence simpler. Therefore, let us first learn how alcohols, phenols, and ethers classified. Alcohols, mono, di, tri, or polyhydroxy alcohols. Alcohols and phenols may be classified as mono, dry, tri, or polyhydric compounds depending on whether they contain 1, 2, 3, or how many hydroxyl groups respectively in their structures as given below. Monohydric C2H5OH, dihydric CH2OH CH2OH, trihydric CH2OH CHOH CH2OH. Monohydric alcohols may be further classified according to the hybridization of the carbon atom to which the hydroxyl group is attached. First, compounds containing CsP3OH bond. In this class of alcohols, the OH group is attached to an sp3 to an sp3 hybridized carbon atom of alkyl group. They further classified as primary, secondary and tertiary alcohols. In these three types of alcohols, the OH group is attached to primary, secondary and tertiary carbon atoms respectively as depicted below. प्राइमरी में सिर्फ एक कार्बन CH2OH अटैच होता है और जो सेकेंडरी में होता है उसमें जो कार्बन CHOH अटैच होते हैं उसके दो और होते हैं और यूं ही टर्शरी में होते हैं उसके 3 अटैच होते हैं कार्बन के साथ और सिर्फ एक OH होता है. Allylic alcohols. In these alcohols, the OH group is attached to sp3 hybridized carbon atom adjacent to the carbon atom double bond, that is to an allylic carbon. Benzylic alcohols. In these alcohols, the OH group is attached to a sp3 hybridized carbon atom next to an aromatic ring. Allylic and benzylic alcohols may be primary, secondary, or tertiary compounds containing sp2 OH bonds. These alcohols contain OH group bonded to a carbon-carbon bond, i.e. to a vinylic carbon or to an aryl carbon. These alcohols are also known as vinylic alcohols. Vinylic alcohol CH2 double bond CH OH. Ethers are classified as simple or symmetrical if alkyl or allyl groups attached to the oxygen atom are the same, and mixed or unsymmetrical if the two groups are different. Diethyl ether C2H5O C2H5 is a symmetrical ether, whereas C2H5O CH3 and C2H5O C6H5 are unsymmetrical ethers. Nomenclature. Alcohols. Alcohols. The common name of an alcohol is derived from common name of the alkyl group and adding the word alcohol to it. For example, CH3OH is methyl alcohol. According to IUPAC system, the name of an alcohol derived from the name of the alkane from which the alcohol is derived by substituting E of alkyl with the suffix OL. The position of substituents are indicated by the numerals. For this, the longest carbon chain, parent chain, is the number starting at the end nearest to the hydroxyl group. The positions of the OH group and other substituents are indicated by using the number of carbon atoms to which they are attached. For naming polyhydric alcohols, the E of alkane is retained and the ending of ol is added. The number of OH groups is indicated by adding the multiplicative prefix di, tri, etc. before ol. The positions of OH groups are indicated by approximate locants. Example, HOCH2CH2OH is named as ethane 1,2-diol. The table gives common and IUPAC name of some alcohols as example. Cyclic alcohols are named using prefix cyclo and considering the OH group attached to C1, cyclohexanol and 2-methyl cyclohexanol.